Hi there, it's Gabor from LVGL. I have a big announcement for you today. We have just released version 0.1 of our UI editor tool. If you have missed our previous preview video, with the help of this tool, you can describe your UI components and widgets in XML files. Later, you can export C code from these XML files, or if you wish, you can also load these XMLs at runtime without recompiling your application. In this video, I'd like to show you step by step what kind of things you can do with this early version of this UI editor tool. The first thing that you need to do is go to this GitHub repository, LVGL/LVGL_editor. Here in the README, you will find a Get Started section. Basically, what we will do is going through all these points here and see how they work, how they look like in the practice. So the first step here, installing Docker. Docker is a dependency of the editor. You need to install it so that the editor can perform some compiling steps internally. By clicking here, you will find the installation guide of Docker so you can easily install it on your system. The second point is download and install the editor. Let's click here. This is the release page of the same repository where we already have a Linux and a Windows version. We will also add a Mac version and the VS Code extension as well. So I'm on Linux. I will download this app image. Fortunately, it's only 300 megabytes, so it's quick to download. It's an app image, and as usual with the app images, you need to make them executable first. Okay, and now you can start it. Great, let's see how to continue. Fork and clone this repository. All right, let's scroll up, click this fork button. I will fork it to my personal account with the same name and just click the Create Fork button. It's required here because we will push back some changes to this repository, so we need to have write access to it. And done. We also need to clone it. Just click here, copy this URL. I will clone it to my desktop. Great. Let's see what's next. Let's continue reading the README in our fork. In the repository settings, set the source of pages to GitHub Action, and on the Actions page, enable Actions. All right, so let's go to Settings. In Pages, set the source to GitHub Actions. All right, and in the Action settings, enable Workflows. All right. Let's go back to the README. Open the editor and load the example folder. We have already opened it. Let's open a project. On desktop, we have our repository and we have an example folder in it. Let's open it. All right, it's loaded. What to do next? Compile the project to generate the custom C code in the editor's preview. Use the button in the top right corner. All right, so let's click Compile Project. This is the step for which we needed the Docker container. Here, the editor compiles all the C code and header files that we have here, and we'll make them part of the editor preview, so our custom code will run inside the editor as well. Project compiled successfully. Great. What's next? Edit components. Open button default.xml, make edits, save the files with Ctrl+S to update the preview. Okay, so among components, we have buttons, button default, and this is how it looks like. As it's a component, this XML description starts with a component tag Inside it we have an API section, some styles, and a view describing how the widget looks like. In the API part, I have a button label property, which is a string, and it's used down here in the view. It's referenced by this dollar symbol, so if this property is used, its value will be passed to the heading text property of h3. h3 is also a custom component. Very simple. It also has a property called heading text, which is used here as the text property of an LV label, so a built-in label widget. I will show how it works in a minute. But take a look at the styles first. So here I have a main and a pressed style. I have some properties here like background color, background opacity, width, height, radius, these kind of things. If I change something, let's say the background color, make it something red, and I press Ctrl S, it's updated immediately. You can also click on it to try it out. If you want to use this widget, I have a little bit of sandbox here where I can try out stuff. So I have this button default, and I use the button label property here. I set hello. So this custom property is propagated to h3, and finally h3 sets it on the label. If I change it to Word, it's updated. I also have a constant here defined in the constants section. It's an int type, the name is long, and the value is 100%. If I change it to, for example, 150, not percentage, but pixel values, it's updated on all the buttons because I used this constant everywhere. Here the width of the parent element is only 50%, but if I change it to content, its size will be set automatically to involve all the content. Alright, so we have tried out the components. Now we should continue with the widgets. Scroll down to see the widgets. We have two widgets here. I will start with the dark slider. It looks very similar to the components. The main difference is that here the first element is a widget, not a component. It also has an API. In this case, we have a color. It has styles, and it has a view describing how it will look like. I can also try it out here. The main difference between the components and the widgets is that in case of the widgets, you can write custom C code, which can be compiled back to the editor so that you can preview your custom C code as well. If you press this generate code button, all these files will be generated for you. The files ending with a gen suffix will be always overwritten, so you shouldn't edit them. But the others are generated only once, creating a skeleton for you where you can add your custom code. Let's see this generated C file first. It looks very similar to the built-in LVGL widgets. We have a class, an object class describing the callbacks and other things of this widget. We have a create function with a parent returning the slider. We have a constructor where the styles are initialized and the children or the widget is created. And we have a constructor hook at the end. We also have a destructor with a destructor hook and an event with an event hook. These hooks are described in this dark slider.c. So this file is not overwritten. This is the place where you can add your custom code. First, I have created a function for our single property called color. So when you call dark slider set color, it will set the color that you pass to the indicator and a little bit of darker version of this color to the indicator when it's pressed. I have nothing special for the constructor and the destructor here, but in the events I have a custom code to describe a little box on top of the knob when you press it and it's moved. I will show it soon. In this dark slider XML parser, you can connect your custom C code to the XML properties. Almost the entire file is generated automatically. I just added this line here. So when the XML properties are processed, this XML apply function is called. And if the name of the property is color, then we call dark slider set color, so our custom function where we can write any kind of code, apply it on the item, which is the current widget, and convert the current value to a color, to an LVGL color. So if we see the color XML property, we will call this API function. Okay, if I go to the other widget, the slider box, where this slider is used, if I move it, you can see this little box on top of it. The slider box is very similar. We have some generated and handwritten files here with some extra logic. So I go back to dark slider. And here in this box drawing code, I will change something and compile it. So the rectangle's background color is some grayish color right now. I will change it to red. Save it and compile the project again. It will be much faster now because it doesn't have to compile LVGL again. And it's ready. Now if I go back to the slider box, now it's red. So the C code that we have written can be previewed right here inside the editor. Obviously, it's a very simple modification, but you can imagine that it can be any complex. All right, now we know the widgets as well. Let's see how to continue. Check out fonts and images. Open globals.xml to see how images and fonts are handled. We have this globals.xml here, where we have enumerated the images and fonts that we are using in this project. So for the images, we have a name. Let's say we have this wink and the source path. It's in the images folder. Similarly to the fonts, we need to tell that we want to use these fonts with the tiny TTF library. And this library can load the TTF files at runtime. Only this option is supported right now. However, later, obviously, we will be able to export the fonts to C arrays, load them with free type, and all the options which are available in LVGL can be used in the editor as well. But for now, for the sake of simplicity, you can just load these fonts from file. So we specify how we want to handle these fonts. We give them a name and specify the source path and the size. So we have 3 fonts here: the small, the medium, and the large, with these sizes. If I go to age 1, for example, here the extra large font is used. If I change it to medium and save it, it will be smaller. But if I change it back to extra large and go back to globals.xml and change the size of extra large to something even larger, like this, save it, go back to age 1, it's larger. So this is how you can describe the fonts and the images. Okay, so now we have checked most of the features of the editor. Let's check out our Figma plugin now. Let's open our Figma project. Here we have created the design of the elements that we already seen in the editor. You don't have write access to this Figma project, so you need to duplicate it first. Let's click this little drop down here and click Duplicate to your drafts. So this version is your local copy where you can do any kinds of modifications. Now click here in this drop down next to the Figma icon. Select the plugin menu, Manage Plugins, and here you can search for Figma to LVGL. It's already listed here for me because I've already used it. Click it, and it will open this little window for you. If you click on any items here, you will see its style properties in an XML format. Like the background color, background opacity, width, height, radius, everything is here. Now I change something like its fill color. I will use this purple. I will also change the radius, make it a little smaller. I can just copy it, and in button default, I can paste it. If I save it, it's updated. Although you need to copy the properties of each element one by one, however, it gives you a great flexibility to put it together as a developer wants. For example, originally I just copied everything from Figma here, but there are a lot of redundant things here. For example, the background opacity might not be required because it's the default value. Width is content, height is content, it's okay, radius is okay, paddings are okay. However, in the press style, a few things are redundant. As a developer, I know that I don't want to specify all these to keep things a little bit simpler. Radius is the same. I want to keep the shadow properties. And I don't want to specify the padding again. If something changes here in the original style, I just want to keep it. Okay, it's working. So this is the initial version of our Figma plugin. It helps you a lot to re-implement the style properties or re-implement the components created by the designer in Figma. However, later we will add a lot more to make it even simpler to synchronize your XML file with the Figma design. What's the next thing? Okay, so we have the Figma project and we duplicated it, and we have also tried out our Figma plugin already. Now we can try out the online preview. Commit and push your changes, wait for the CI to run, and check the online preview. So I open a terminal here. There are some changes. I commit them and push them. Okay, let's go back to our repository. I refresh it, and now an action is running here. Let's see. Publish tests. All right. It takes a few minutes to complete because it needs to pull a few things and compile LVGL, compile your C code as well. And it's done. Now you can see something on the GitHub pages of this repository. Here this link is still coming from the original repository, so you need to change this LVGL to your username where you have did the fork. So this is the online preview. Here you can see all the components and widgets that you have created online in a web page. It can be accessed from anywhere. It's an incognito window right now, and it's working from here too. So it's a simple way to share your work with your team, with your marketing people, designers, your clients. If you upload something just to GitHub, this page will be generated automatically. You can just send a link and anyone can see what you have done. For example, in this home.xml, we have a little bit more complex view where the button component is also purple because we have updated it from Figma. Here we have this red box because we have updated it from code. So what we have here is really compiled from the C code because we have added this red background color modification. These events to increment or decrement the slider value are also coming from custom C code. Let's continue with what we can do with the exported C code. So in the editor, we have already seen a lot of C and header files generated when this generate code button is clicked. I have prepared an Eclipse project already, which is just a basic LVGL project. We call LV init and some driver init functions with this screen resolution. Let's open a terminal and copy our examples to the Eclipse project. I just remove my previous code and copy all these. In Eclipse, now I call this UI test from C. It's in the UI test file, which is also in the example folder, just to make it easy for you to try it out. So the first thing that you need to do here is call UI init. You need to specify a path from where the fonts will be registered and some basic stuff will be handled. After that, this home create function is called from this file. So the generated file of the home component. We have a home create file where we have a lot of stars and some view created. If I compile it and run it, it works, but this button is not purple. It was purple. It happened because we haven't clicked this generate code button. So we have only updated the XML, but the C code here is not updated. So let's click the generate code button. Copy these again. And now it's purple. We also have the red box here. So now we have used the C code as it was exported or generated. However, if we wish, we can also use the XML files. In this case, let's use this UI test from XML, call the same UI init function. In this case, we need to tell the XML parser how to interpret these font names. We have these fonts somewhere in our application. We once assign them to some names. Also register our components and our widgets. And at runtime, parsing the XML file, we create this home component again. Let's see how it works from XML. Looks the same. Now I change something only in the XML. Let's say change the background color of the default button. Save it. So I don't generate the code again, just updated the XML. Run it again, and now it changed. So this way, if you get your XMLs from an SD card, from the internet, Wi-Fi, Bluetooth, whatever, you can update your UI without recompiling it. So this is what we have right now. We have checked the components, the widgets, the Figma plugin, the online preview, the exported C code. We have loaded XMLs at runtime. And now at the end, I'd like to answer a few questions that you have asked recently. First, multiple people were interested about what is our relation to SquareLine Studio. So I was working on SquareLine as well, but there I wasn't a decision maker, and I felt like I like to do several things differently. Finally, a year ago, we have separated our ways, and I decided to develop an editor according to my best understanding about the needs of the users of LVGL. Having this decision in mind, I conducted a lot of research about the real needs of people and companies, and found several people to work on this tool together. Now LVGL LLC is a 9-person company, and we have reached a huge milestone together. But this is just the first step. Version 0.2 and 0.3 will come in the upcoming months, and we are planning to release version 0.1 in September. You've also asked if this tool will be open source or not. So this is a closed source software. We will provide a free version for it, which will be suitable for most of the smaller companies and makers as well. Basically, what you have seen right now in the editor with some extra will be available for free. However, we believe that the Figma plugin and the online preview and similar collaborative tools are more interesting for larger companies where there are separate designers and developers working on a project. So to access these tools, you will need to pay a licensing fee. We also like to solve some of the issues of the enterprise level companies where they want to have very custom workflows and they have very special needs. For these companies, we would like to provide a plugin system where they can configure and modify the editors by adding custom buttons somewhere, parsing custom XML tags, adding new code export features to support other languages, and these kind of features. To support the open source projects, we would like to find a way to provide a free version of the licensed version for people working on open source UIs. So that's what we have right now. I'm very, very curious to hear your feedback. If you would like to tell what you have experienced, please go to the original LVGL editor repository, not your fork, and open an issue here to tell how it works for you, what features have you missed, what did you like, what did you dislike, or just what's your opinion in general. Thank you very much for your attention. See you on GitHub. Bye-bye.